Hello everybody, welcome to my class. Before I start the class, I first like to wish you happy Vijayadashmi. On the occasion of Vijayadashmi, may Goddess Durga bless us to embellish us with all progress and prosperity. Today, uh, our topic is trapezium rule, and trapezium rule is kind of uh, finding the area under a curve between given range of values of x. So we are now going to start what is trapezium rule and how we apply that to the problem area. Okay, so we'll talk about the trapezium rule. This is not the part of pure mathematics paper 3 in A level. In fact, this is in paper 2, and this might not be applicable for who are taking paper 3, 1 and 3, but this is important to understand what is trapezium rule. You can see here that this is an estimate of the area under given curve. That means it doesn't give you the exact area, although you will be able to find the area very close to the true area. So here in this case, before we go further into the trapezium rule, you have to understand that what is the area of a trapezium, for example. So area of a trapezium is equal to that trapezium looks like something like this. If these two sides are parallel, this is also called the trapezium. So for example, say this side length is A and this side length is B. The A and B are parallel in this case, and it has some width between these two. So this is the width, say this is S for example, and here you can see that say this side length is A and here this side length is B, and its width, that is also called the height also, so this is H. In that case, it is found that the area of trapezium is half times of sum of length of the parallel sides. So generally we write sum of the parallel sides. That means the length of the parallel sides times width. Width can be height also. Okay, so width means the distance between the two parallel sides. So here you can see the distance between two parallel sides is S. You can call it as height over here. And here you can see that the distance between A and B is H. So here in this case we can call it as width. Alright. So what you can see here in this figure, that in this figure you have curve, and you can name this curve as y equals to fx. So y equal to fx means this is the function of x and it has some shape, and so at this time I suppose that curve has shape like this, and I'm interested to find the area under this curve in the range of values of x equals to a and x equals to b. So in general, by integration method, what we do actually, we integrate the given function fx in the given range of values of x. For example, here it is a to b and dx, and it gives you the area under the curve between the values of x equals to a and equals to b. But what happens sometimes, for example, if you are given simple integration function like this, 1 by x dx, and if you would like to find the area from 1 to 5, say, it's quite easy to find the area. This is ln x, and then you take the range of value of x from 1 to 5, and then your area is ln 5 minus ln 1 unit, so a square unit. So these are the easy things that you can find by integration. But what happens, for example, if you are given that ln x dx, and if you would like to find the area under the curve lx for the value of x from 1 to 5, this is still not difficult. But what happens actually, we cannot find it quickly in fact, because you have to take the integration by part, and it requires a lot of time. For example, you can see that how you can do this. So it is ln x and times this is 1. So nothing is there, that means you can write here 1. So 1 time ln x is itself ln x, and from 1 to 5, so I'll write this value later. And here what I am interested in to do that, so I suppose ln x as u and this 1 as v in this case. So this is the ub rule for the integration, called the integration by part, and its formula states that if you say this is u and this is v, then you can use one of the formula. There is another way of expressing the formula for integration by part. So here in this case I'm taking u as this, so u v dx minus sign of integration, start the bracket, and then it is du by dx, then again sign of integration v dx and whole dx here. So now what you can do in this case is you can put in place of u ln x, so I'm putting here ln x, then sign of integration, v means I have supposed v for 1, this is 1 dx, and then it is minus sign of integration bracket du by dx. U means we have ln x. So this is up to us that how we suppose u and v, so that our work will be easy and integrable. So by dx, and then it is v dx means v, we have in place of v we have 1, so we write here 1 dx, and then dx of everything, integration of everything inside this bracket. So let me select out. So I am clearing off this sort of thing here in order to have some space, and then it's done now. It is continues from here. So it is ln x times derivative of 1 is x, this is x, and minus sign of integration, and then it is d ln x means it is 1 by x, and times derivative antiderivative of 1 is x in here. So and this is dx, x and x they got cancelled out, and then it is x ln x minus 1 dx, and finally you have x ln x minus 1. So antiderivative of 1 is x, and now our range of values for x under which we are going to find the area of the curve ln x was, it is 1 to 5. So you can put here that is 1 to 5. So 1 to 5 means then you put this value first 5, so it is 5 times of ln of 5 minus 5, and then minus in between that, and then another value is 1 here, so you put here 1 times ln of 1, in fact this is going to be 0, and minus this is going to be 1. Close this bracket, and once you calculate this either in decimal form or in exact form, so it will be the area in square unit. That means by using direct integration method we can find the exact area of the given curve between the given range of values of x. Here in this case this is 1 to 5, so in general we can say this is a to b. But can you imagine how long will you take to this take in order to calculate the area of this sort of curve, where it requires the integration by part? It takes a lot of time. Although it takes a lot of time, it doesn't matter if you are getting the exact area, but sometimes if you want to have quick calculation of the area, this is not necessary that you calculate the exact area, in fact. So by taking less than half time than we have done this way, if you are able to find very nearest value to the area that we got through the direct integration method, in those cases it will be wise to go through the trapezium rule. So now let's discuss what is trapezium rule and how we deal with how we apply this sort of rule to the problem area. Now here you can see that this is a curve that we supposed to have got it out from the function y equal to fx, and we are interested to find area under the curve between x equals to A and x equals to B. So in that case, what we have done actually, we have considered 1, 2, 3, 4, 5, 6, 7, 8. 8 strips between x equal to A and x equal to B, where each strip has the equal width, but the lengths are different here. So in this case, if I'm interested to find the area of the first strip, that is the first trapezium, in that case what we can get here, so we say area of first trapezium as 1, and you know that this is half times of, or you can say that this is width by 2 times sum of the parallel sides, sum of the parallel sides. Then the area of first trapezium, that means we are talking about this trapezium, okay, so that is going to be, width is h. So note that we have same width for other trapeziums as well, but the heights are different here. So this is s by 2, and then sum of is one side length has value y0, say, and another has y1, and these two are parallel sides because we have to take this vertically to the x-axis. Similarly, these two are also parallel. So similarly, if you would like to find the area of another strip, that means another trapezium, that means we are talking of this trapezium now, we are talking of this trapezium, you can see that its width is h, so we write again here h by 2, so this is h by 2, and times the length of the parallel sides. So here in this strip, one side has length y1, so right here y1, and another parallel side has length y2, so we write here y2. Alright, and similarly you will be able to find the area of third strips, fourth strips, fifth strips, sixth strips, and seventh, and also the eighth strips here. What will be the sum of areas of all trapezium in this case? So that sum of the areas of all trapezium is, definitely it is going to be area of first trapezium plus area of second trapezium plus area of third, fourth, fifth, sixth, seventh, and eighth. You may consider only 6, or if you like you may consider 18 strips. This is up to you, that how you make your work easier or how it is instructed in your problem area. It depends on the facts given or decided or suggested. Okay, so here after this step, so area of first strip is s by 2, and area of second strip also has s by 2. So s by 2 will be common from the formula for the area of each trapezium here. So we take out s by 2 common, or otherwise you can just write s by 2 yo plus y1. So this is for the first, that is a1, and then s by 2 y1 plus y2 plus y7 plus y8. Okay, so let's see how the terms are here. Now you can see here y0 is only one time, and also y8 is only one time, but rest of the things, for example y1 is twice here, similarly y2 is twice here, and up to y7 you will see that you will get the 2 times of y7. So we continue from here. Then you have h by 2, and inside the bracket, as we have seen that yo and y8 are only one, so we keep them together, and rest are 2 times, then we keep them in another bracket altogether. So this is y1 plus y2 plus y3 plus y4 plus y5 plus y6 plus y7, and it will be the approximate area under the curve for given range of values of x. So here in this example, you can say from 1 to b, it can be from 1 to 7, 0 to 9, or something like this. So why we wrote here approximate area? Because it will not give you the exact area. Why it will not give you the exact area is that you can see, if you consider this sort of trapezium, then you can see that there is a little gap between this straight line and the curved line over here. It means while calculating the total area or the total area of all this trapezium, we are missing out some sort of information to take into account. So although that is very little, but we are missing out it. So in this case, if you suppose from here to here, we are underestimating the area. And in another trapezium, if you consider this is outside of this curve, this line, straight line is, so there is some areas between the curved line and the outer straight line, but we are not taking it into account while adding areas of all this trapezium. So in this case, we are overestimating. So in the course of adding area between x equal to a and b, somewhere we are underestimating, somewhere we are overestimating, and hence we are suffering a bit of error, and therefore we say that the area that we have been calculating using the trapezium rule is only an estimate. It doesn't give you the exact area. So let's see that what will be the value of h in this case. So here you can see that between a and b, so this difference is, if you talk about this difference, is going to be, if you talk about this difference is from o to b, this is b, and from o to a, this length is a. So length of ab is b minus a. Okay, so within b minus a, how many h are there? You can see that 1h, 2h, 3h, 4h, up to 8. So we have 8 h in this case. Therefore, each h is equal to b minus a by 8. What does it mean that? It means that if you are given the 8 strips here, then in the difference of the highest value of x and the lowest value of x, that is, and you divide by the number of strips, that will give you the value of h. So here we talk about the 8th strip. So in that case, our area was h by 2. It was y0. If there are m trapezium of equal width, say it is h, in that case, what will be the formula? The formula will be like this. H is, h by 2 is here, and then this is y0 plus yn. So this is the first value and this is the last value there, and we have already seen that these values are only once there, and then rest of the values will be like this: 2 times of y1 plus y2 plus y3, y4, and then it will go up to yn minus 1 in general. N minus 1 means 1 before yn, 1 step before yn. So this should be the formula in general, and here in this case your h value will be b minus a by n, because in this case you can see that the number of trapezium is n, so we divided by n, so therefore it is b minus a. So in this way the theoretical idea or the general idea to calculate the area by using the trapezium rule is developed now. Now let's go to the problem area. Okay, let's see. This is we have to find the integration of 1 by x under the range of values of x from 2 to 8 in this case, so that it is also possible to find by the area by direct integration. But let's see what happens and what difference you get when you find this by direct method and also by using the trapezium rules. So just earlier we have seen the trapezium rule in, so let's talk about how to apply the trapezium rule to the problem area. So here in this case, like if you consider graph from 2 to 8 means it is 2 and this value is 8, So let's check what happens if you put x equals to 1, for example. This is if x is 1, y is also 1. Good. And if x goes on increasing and increasing towards infinity, then it will reach near and near to the, it will go near and near to the y-axis, but never touch. And from here it is like this. So we have considered the trapezium. So now let's see here. This width is h here, and this is also h, and this is also h. So each strip has the equal width. And then take this point as this is 1, not 1, actually it starts from 2 to 2, then we say that this is 2, and this is 3, this is 4, this is 5, 6, 7 and 8. If you so if you'd like to say that it is y2, height is y2, and its height is y3, its height is y4, this is y5, y6, y7 and y8. And you remember the formula to find the area. So area in this case in general is h by 2. So first and last term has only one value, so y0 plus yn in general we call it, and then plus it is rest of the values, so y1 plus y2 plus 2 times of, and plus dot 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 plus it is up to yn minus 1. So here if you say yn is equal to y8, so yn minus 1 is y7, and in place of yo you can take it as the length of the or height of the first strip in this case. So it is y2 is as yo in the formula. Okay, so let's take the area, how to find the area of this sort of thing. So area is actually in this case it will be given by h by 2, and its first value, initial value is yo, so here initial value is y2, so we can write here y2, and the last value is yn here, so here last value of the height is y8, so we write here y8, and then rest of the things are 2 times over there, so 2 times are y3, y4, y5, so this is y3 plus y4 plus y5 plus y6 and y7, so plus is plus y6 and plus y7. So this is the formula. Now we'll like to find what is the value of h here. So h in general is, you know that h is b minus a by the number of strips. So here b value is, you can say this is a and this is b value. So b minus a means you can write here 8 minus 2, and divided by n means the number of strips are, how many are there, you can check it. So 1, 2, 3, 4, 5 and 6, so we put here 6. So our answer is, not the answer, actually the value of that equal width is 6 divided by 6, so these two are cancelled out and its length is 1 unit. So we found the value for h now. Now let's talk about the value of y1, y2, y8, y3 and something like this. So in order to do so, let's develop a table first of all. So we have table like this, and then we take the value of, here the value of x, here we'll have look at the value of x, and here we look at have the value of y, which is given as 1 by x, or we can say fx also, y is fx, so it is, yes, so this curve is for y equals to fx equals to 1 by x, that means along the x-axis there is value of x, along the y-axis there is value of 1 by x. So here in this case, what are the values of x in this case? You can see that here 2, so we write here 2, then another value is 3, so it is 3, 4, 5, 6, 7 and up to 8, and now 7, and this is 1 over 8. So our table is ready now. So by using this table and the formula, we'll find the estimated area under the curve 1 by x for the given range of values of x from 2 to 8. So let me clear it off first of all. So I'm clearing off this space now. So therefore the total area under the curve 1 by x for the given range of value of x from 2 to, we are talking from 2 to 8, is the total area. You can say A is h by 2. You can see here h value is 1 and this is half, and then this is y2 plus y8. So you can see here y2 is 1 by 2 and y8 is, you can see here 1 by 8. So y8 is 1 by 8 here. So you can write here 1 by 8, and similarly value is like this. It is 787. It is 787 divided by, using the calculator, this is 560 in my calculator. This is 560. And even if you like to express that in decimal form up to some significant figure or the decimal places, you can see it like 1.405. So I'll take up to 3 significant figures. So it's going to be 1.41 square unit up to 3 significant figure. Alright, so my estimated area under the curve 1 by x between x equals to 2 and 8 is 1.14 square units. Now let's see what happens if you calculate the same area by using the integration method, the general integration method. So using, now alternatively you can see finding area by direct integration. Let's see what happens in this case. So you know that here the area in this case is integration of the given function fx dx, and x belongs to R, means any real number. So in this case the given range of values of x is from 2 to 8, and fx value is we have 1 by x. That means it is 1 by x dx, and you know the integration of 1 by x is ln of x, and is from 2 to 8 equal to, now the general rule is that first of all take the upper limit 8, then minus, then lower limit here it is 2. Now take your calculator and let's see what is this value. So this is ln of 8, that should be in absolute value, and minus ln of 2, and then this value is 1.38. so that value I obtained is 1.38 or 386, means we can write here 1.39 square unit. If I round this off up to the 3 significant figure or up to the 2 decimal place. Now let's check here what is the difference between these two. You can see that by using direct trapezium, by applying the trapezium rule directly in order to find the area under that curve, our value was 1.41 square unit, and by using the integration method you to find the exact area of the 3 significant figure. If you say it is 1.39, if you compare these two values, this is 1.39 and it is 1.41, these are very close to each other. Alright, that means although this function is it is quite easy to calculate the integration for this function even in the definite integral form, but what we can see from here that by using the trapezium rule, and if you feel if this is very complicated to integrate the function, especially if it cannot be decomposed algebraically into the integrable form, it will be difficult, so that even if you get the rough estimate of the area, that will work in our practice. So in this objective of this was to show you that how close the value of area we find or we obtain by using the direct integration method as well as by using the trapezium rule. Okay, now let's discuss that how to find the integration of function like this. So here in this case your function is like x squared and e to the power minus x dx. So this is a kind of product of the two functions of x in this case. So it requires the use of integration by part. So you can have two formula to use the integration by part, like let u equals to x u equal to gx and v equals to hx, and your function fx is given in terms of gx and gx times hx, for example. So this is the product of two functions of x, gx and hx. That means u equal to gx means u is the function of x, v equals to hx means this is also the function of x. So product of function of x is again the function of x. And if you are going to find the integration of this kind of function with respect to x, that you can also write it as integration of this function is I, and this is u, and this is v dx. So u is function of x and also v is the function of x. So in that case one formula is u v dx minus sine of integration du by dx inside the bracket, and then again integration sine v dx, and after the bracket again this is dx. And one application I have already shown it before. You should be able to decide whether x squared should be taken as u or it should be taken as v, so that our integration is going to be easy. So this is up to you to decide it. So once you decide x squared as u and e to the power negative x as v, if it works then fine, otherwise you just interchange the position. You can suppose e to the power negative x as u and x squared as v. So it depends on how experienced you are. So if you have good practice of this, you can easily think of. Otherwise also there is no problem if one way, if uv way doesn't work, then you can go through bu way. So this is one way of calculating the of finding the integration by using the integration by part method. This is called the integration by part method that you already know or you should know about. And alternative formula for the integration by part is, we are given that dx over here. So this is also the formula that you can use in order to find the integration by part. So my suggestion is to that we use two of both this formula, but no problem if you can remember any of these. But in your formula booklet you will find formula like this if you are integrating the function by part. So let's clear it now. So here in this case your function is like x squared e to the power negative x, and of which you have to find the integration by part for the given range of values of x, for example in definite integral case. So what you can suppose here, first x squared I have supposed as u, and the second function of x e to the power negative x as dv by dx, and my situation is like this. Or sometimes it is easy to take x squared as dv by dx and e to the power negative x as u only. So it depends on how you make your work easy so that you can find the integration. So here in this case, by applying the integration formula, we have all this position. This is x squared, so result is uv, you can see here. So u means we have x squared, so I just put x squared, and in place of v in this case, if I am going through this formula, then it is dv by dx. So let's see here, dv by dx we have supposed as e to the power negative x. So taking integration to the both side, v value is now negative e to the power negative x. So that I did the same work over here and my answer is like this. But here again we require a kind of integration by part again, because this term hasn't been broken completely. So I took this as another integration that I call it is I1. I apply the same formula, and integration of that part is this equation 2. Now I put this equation 2 in 1, then I have the complete integration of the given function. Now if I would like to integrate, find the definite integral from 1 to 5, then it is then its integration value is, definite integral value is 1.59 if I am taking up to 2 decimal places here. So here it is up to 2 decimal places. So that value of area, I will say, by this definite integration is 1.59 up to 2 decimal places. So here you can experience one thing is that how long did you take to calculate this area. Although this is very correct and exact value, but it requires a lot of skill, and there is no doubt on your skill, but there is the matter of time. It requires a lot of time to calculate this sort of definite integral. But if you are in quick need of the area, even though instead of 1.59 if you get 1.61 or 1.5 1 point something like this, very near to 1.59, and if it works in your practical area, then this is wise to go through the trapezium rule. Another example, I'm doing the same problem by using the trapezium rule. So here you can see that this is the graph or the curve space for y equal to x squared to the power negative x, and this problem states that the diagram shows part of the curve y equal to x squared to the power negative x. Use the trapezium rule with 4 intervals to estimate the values of x squared e to the power negative x dx from 1 to 5, giving your answer correct to 2 decimal places. So let's see what value of area we get by using the trapezium rule. And it says that you have 4 intervals to draw over here. 4 interval means interval of equal width, and it starts from 1 to 5. So let's suppose this is 1, this is 2, this is 3, this is 4, and this is 5, right? And then you can consider the trapezium like this. Your trapezium will be like this, and it will be like this, it will be like this, okay? And say it is from 1 to 5, so you can write here, take another pencil. So say this is y1, and this height is y2, this height is y3, and this height is y4, and this is y5. So we have how many strips? 1, 2, 3, 4 strips. That means we have 4 trapezium in this case. And you can say that width of each is h. So here h, here h, and here h. And the value starts from 1 and it goes till 5. That means in between values are, this is 2, this is 3, this is 4, and this is 5 itself. So what will be the value of h in this case then? You know that if you would like to find value of h, that means it's going to be b minus a by n. So here in this case, b means this value is b and this is 1 as a, because it says that 1 to 5. So it is b is 5 and minus a is 1, and then you divide this by how many strips are there. Number n means the number of strips, so it is 1, 2, 3, 4. So there are 4, and the question also says there should be a 4 interval, so we divide this by 4. So it is 4 divided by 4 is 1. And we know the formula for the area under the curve x squared e to the power negative x from the values of x from a to b is, here in this case it is h by 2, and see here that y1 is the first value and y5 is the last value. So in the formula, the first value and the last value should be only ones, and then rest of the values are 2 times of that. So rest of the values between 1 and 5 are, you can see, 2, 3 and 4. So you can write here, this is y2 plus y3 plus y4. And now we'll develop the table, and then we'll get the values of the total area. So in this case, let's have the value of x and value of y. This is the value of x and this is the value of y, and y is equals to, in this case, is x squared and e to the power negative 2. So value of x's are, you can take, it is from 1 to 5. Yes, you can see this is from 1 to 5. This is from 1 to 5. So you write here 1, you can write here 1, 2, 3, 4 and 5, and then take some vertical line like this, or take a scale and make a table like this so that it looks nice. And then you take a calculator. When you take a calculator, put in your calculator, you will have, for the first value, it is x squared, means it is 1 squared times this is e to the power negative x. So this is e to the power negative x. So times e to the power negative 1. And when you use the calculator, this value is, I have found this value as 0.368, and the y4 value is 0.298. Close this bracket, and then again using calculator, your value will be like this, 381 divided by, it is 250 in the exact form of calculation, and if you put that into decimal, you'll get 0.524. If you express that to 2 decimal places, it's going to 0.5222 dp, or 3 significant figure. So now let's see what is the difference between the values that we have got through the direct integration method and by using this trapezium rule in order to find the area under the curve between x equals to 1 to 5. So that value was, yes, it was 1.59 by using the direct integration method, you can see here. And now by using the trapezium rule, our value is like this. So you compare this value by using the trapezium rule, and the another value 1.59 by using the direct integration method. You'll see there is a bit difference, but there is a little difference between these two values. Now what can you say about, although the in fact by using the trapezium rule we can't reach to the exact value of the area, but we estimate the area nearer to the given area, or near to the area covered by the curve under the given values, range of values of x. So here by using the direct integration method, our value is like this, and by using this trapezium rule, value is 1.52. if you consider up to 1 decimal place here, it is the same value. So although these two are not the equal values, these are very close to each other. Okay, so here we discuss about the benefit of going through the trapezium rule is that although we didn't get the exact value, but it's very near to the exact value of the area, which is a very good estimate about that area. And if you compare with the method, in fact, in this case, so if you talk about method, it requires a lot of time. If you take 10 minutes to, or for example, say if you are doing quickly, if you take 6 minutes to do this, but using the estimation by trapezium rule, you can do this within 2 minutes only. So that is also another benefit of using the trapezium rule. Now we'll discuss another question of, and also you can see that last thing is that the estimated area is 1.52, but actual area is 1.59. That means the area that we have estimated is underestimated. And this can also be evident through the figure. You can see that why it is underestimated. So between 1 to 5 you consider 1, 2, 3, 4 trapezium, and in each trapezium you can see that we added this area only and left out the area that you can see between the curve and this line. Alright, that means this sort of area we didn't count in order to find the area. And this sort of line all lie, or most of these lie under this curve, leaving some gap over here, and this is the reason why we got the less value than that, the exact area 1.59 up to 2 decimal place. So this suggests by value also the area has been underestimated by using the trapezium rule, and also it is clear from the figure that all these trapezium, especially if I talk of except these three, they are a little out, but all these rest of the trapezium are inside this curve. That means it is not taking into account the entire area under that curve, and this is the reason why this is called the underestimate. So in this case, by using the trapezium rule, we underestimated the area. Okay guys, lastly let's see that how do you find the area under the curve given. So in this case, if you'd like to have look at this sort of equation, for example, or this sort of function, do you think it can be integrated directly? No. Can this algebraic form be splitted into the integrable form? Answer could be yes. Sometimes no. So here, for example, this is given under root of 4x minus x squared, and then that means it is 4x minus x squared to the power 1 by 2, and if you use the binomial expansion, you will have separate term of x's with some constant coefficient, and by breaking in that way, you will be able to find the integration of this function. So in order to do so, first of all you require the skill of binomial expansion. Okay, even though you know this method to expand and split that into different terms that can be integrated, it requires a lot of time and effort. Okay, so in order to save your time, this is wise to go through the method of trapezium rule, where you will not get the exact area, but you can estimate up to the very near value to the exact area. If you like, or if you want to have some few more times, you may pause here and then take out your notebook and pen and then try yourself before looking over my explanation that I'm going to explain. Okay, let me explain you now. So here, first of all, it says that the diagram shows the curve y equal to under root 4x minus x squared. Use the trapezium rule with 4 intervals to estimate the value of this integration, or the value of the area, giving your answer correct to 2 decimal places, and then state with region whether the trapezium rule gives an underestimate, or overestimate of the true value. So what you can do in this case is that, so in this case it says that how many strips you required here, trapezium with 4 intervals. So it starts from 0 and it goes up to 4. So start from 0 means what you can do, actually we consider this is 0 position, and then so this is 1, this is 2, this is 3, from 0 to 4, so 1, 2, and this is 1, and this is 2, and this is 3. And if you consider trapezium, so length at O is 0, so we made this line like this, and length at 4 is also 0, that means y is 0 at 4, and then you made them like this. So this is also a trapezium where one side has length 0, and here this is also another first trapezium whose one length has value 0. So this is also a trapezium. And now consider another trapezium, and this trapezium. Let's see here. All these straight lines lies under this curve. That means although we are going to estimate the area very close to its true value, but we are underestimating in this case. So in order to do so, first of all, what you can do, like you have yes, first of all h you have to find. So if you would like to find h, first of all, h is actually b minus a by n, that is b value is the highest value, that is 4, and the a is the smallest value, that is 0. And how many intervals it has? 1, 2, 3, 4. So 4 strips it has, so this is divided by 4. So value of h in this case is again is 1, and the area will be given by the formula. This is h by 2, and then it is, so you can say this length as y0, it has value 0 in fact, and this length is y1, this length is y2, this is y3, and this length, 0 length, is y4. So y4 again here in this case is 0. So by using the formula for the trapezium rule, and then inside the bracket it is the y0 and y2, that means y0 value is 0 over here, and y2, no, this should be y4, sorry, this is y4. So plus y4 value is again 0, so it is 0 plus 0, and then plus it is 2 times of rest of the value. Y1 is 2 root 3, and then y2 is 4, and y3 is again 2 root 3. So by using calculator or otherwise, okay, your final value in this case is, or if you use calculator, it will give you 4 root 3 plus 4, and your final value up to 2 decimal place is 0.93 square unit. All right. So area under the curve, 2 times of 4x, 2 times of 4x minus x square under the values of x from 0 to x equals to 4 is 10.93 up to 2 decimal places as suggested in this question. So this question says that giving your answer correct to 2 decimal places, this is our answer up to or correct to 2 decimal places. Now it says that you can see state with reason whether the trapezium rule gives an underestimate or overestimate of the value. So area in this case we have got as 10 plus 93 square unit, but from the figure if you see that there are a lot of gap under this curve between the straight line and the curve line. Therefore all these lie under this curve with some gap between the lines and the curve. That means while calculating this area, it didn't take into account some of the areas under the curve. So therefore we can say that of the area gave underestimate of the true value. All right. So it will give you the underestimate of the true value. So in this way we can apply trapezium rule in order to find the area under the curve for the given range of values of x. Okay, the same problem you can see here, that this is the way that we do such sort of problem using the trapezium rule. Okay, that is all for now, and thank you for your patience. Take care during this corona season, and once again happy Vijayadashmi to you all.